Let's look at another example. Find the general solution of this guy here, which notice again has that form dy dt equals a of t times y plus b of t. So a of t is going to be the coefficient of y. B of t is going to be negative 4t. And I'm going to put a plus sign between them because I see that in order for these two things to match, for the template to match the function, it's got to be a plus something. So my b of t is actually negative 4t. So step one, find y sub p. I'm sorry, y sub h. You could find y sub p first. There's not a specific reason why we solve y sub h, just because we're used to it. So what we need to do is we need to solve this differential equation. Now, as above, I'm not going to put y sub h here. We're just going to call the result y sub h to this differential equation. I just don't want to have to keep copying down y sub h. So I'm going to divide by y. You can see that by now that this is going to work out to be k e to the 0.2t. But if I now integrate with respect to t on both sides, I'll get natural log of y equals 0.2t plus c. When I exponentiate both sides, I'll end up with k e to the 0.2t. All right, that's what we're going to call y sub h. So I found my homogeneous solution. Step two, find y sub p with the method of undetermined coefficients. And so here is my equation. Again, I'm going to move the y term over. You don't have to do that. You could leave it as is, but I'm going to leave the negative 4t here. Now this one's a little bit different because when I read this, I see that if I take the derivative of my solution and I subtract away 20% of that solution, I should end up with a linear function, negative 4t. But the problem is that if I take y to be a linear function, its derivative is a constant function. So what I will do is I know that if I take the derivative of a linear function, if I call y sub p, if I say it's going to be some sort of linear function, a, maybe I don't want to use a here because I'm kind of using a of t up here. Let me write this as some constant times t plus some other constant. And the reason I have to do that is because once I take the derivative of this, I am going to end up having a linear function. I'm sorry, we don't really need the d on there because that's not going to influence our derivative. But if I take the derivative of yp, I'm just going to get the constant c. So now, if this is in fact my guess, right, I'm just guessing that the solution is going to look something like this, then I better be able to find the value of c that makes this equation true. So I'm going to again plug in the derivative here. I'm going to plug in the function here. And so c minus 0.2 times ct has to equal negative 4t. And I need to find the value of c that's going to make this equation true. So if I do the subtraction on these, the best that I can do here is factor out a c and make this 1 minus 0.2t equals negative 4t, or better yet, let's write it like this. Let's write it like this. Let's say that we leave this as negative 0.2 ct plus c has to equal negative 4t. So in order for these two equations to be equal, this coefficient of t has to equal the coefficient of t on the right. But in order for the two sides to be completely equal, then it would have to be the case that the only thing that I have left on the right is a plus 0. It would have to be true that c is equal to 0 in order for the purple pieces to be equal to each other. But that's a problem Because if c is equal to 0, then this whole coefficient here in green will be 0, and that will not allow me to get that to be equal to -4. So one way around this is to say, well, I kind of need another dial to be able to turn here. And the trick to problems like this is that if you know your solution, your function needs to be linear, then start off with a full-blown linear equation. So make this ct plus d. The derivative of ct plus d will still be c, but what advantage this gives me is that now, in the substitution for y, I'm going to erase this stuff here and kind of go back to the drawing board, is that now the left-hand side in the parentheses will be ct plus d, and that has to equal -4t. So watch what happens. If we distribute things through, we'll have c minus 0.2 ct minus 0.2 d has to equal -4t. Now I see that I have that t term here, so I'm going to write this as -0.2 ct, and then I have left over c minus 0.2 d. And that has to equal -4t plus 0. And the reason I write it out like this is because this coefficient here has to equal this coefficient there. That's the only way that the t terms can be equal. Also, I know that c and d are just some constants, so c minus 0.2d is also a constant, and that constant has to equal 0. So basically what this gives me is a system of equations to solve where I must, so system of equations that must be true is -0.2c has to equal -4, and it must also be the case that c minus 0.2d equals 0. Now this equation allows me to solve for c right away. So if I divide both sides by -0.2, I will get 20 as the value of c. And now what I can do is substitute in 20 for c here and make this 20 minus 0.2d equals 0. And now I can solve for d, and I get d is equal to 100. Great, so as long as c is equal to 20 and d is equal to 100, these two sides will be equal to each other, and so my y particular should be 20t plus 100. Okay, so my y particular, so therefore my y particular is going to equal 20t plus 100. And you can just double check that we solved for the correct term. If I put in 100 up here for dy dt minus 0.2 times 20t plus 100, and you distribute that through, -0.2 times 20 is going to be -4, so that'll give me the -4t. -0.2, I'm sorry, this shouldn't be 100. This right here will be our 20, because that's our value of c. -0.2 times 100 is -20. -20 plus 20 is 0, and so then I'll just have -4t on the left, -4t on the right, and so they are in fact equal to each other. What we did here again is the method of undetermined coefficients. We started off with a guess that wasn't quite right because we left off this plus this constant term. But when we put that constant term on there, what it did is it allowed us to balance the equation, and that value of d allowed us to ensure that c didn't have to be 0 like it did when our guess originally involved the lack of that plus d. So another key advantage here is that if you see that you want your right-hand side to equal a linear function, then your y particular should be the full-blown form of a linear function. If this here was quadratic, then this should be a full-blown quadratic. If this were cubic, this should be a full-blown cubic.